In this video, we're going to continue our adventure into complex numbers and definitions of I, the imaginary unit. So let's keep going here. In that last video, we solved this problem. And we discovered that x has two values. It is either positive 3i or it's negative 3i. Okay, so we're at a point now where we would like to check our answer. How do we check a value for x that involves an imaginary number? Well, we need to know a new definition for I. So remember, our first definition for I was I is equal to the square root of negative 1. But in order to check this, we're going to have to know that, here, let's do it. We're going to have to know what I squared equals. So if we square both sides, we can get it. If we square this side, we get I squared, right? If we square this side, well, squaring a square root gets rid of the radical, and we're left with the number underneath. So I squared is equal to negative 1. And we're actually going to use that quite a bit in the next video or two. So let's try and practice that. Let's check these answers, and we'll end up using what I squared is. So let's check positive 3i first. So if I substitute 3i in for x, we have 3i squared. Does that equal negative 9? Well, let's see. We square everything inside the parentheses. So 3 squared is 9, and I squared is I squared. Okay, well, we said that I squared was negative 1, so really this is 9 times negative 1, and that does equal negative 9. So that works. Let's try the negative 3i. If we square that, does it equal negative 9? Well, negative 3 squared is negative 3 times negative 3. That's a positive 9. And I squared is I squared. And if you remember, I squared is negative 1. So this is really 9 times negative 1. Well, that equals negative 9 as well. So that's why we got two answers, two imaginary answers. And we just use this new definition of I squared equals negative 1 to check it. Alright, so let's get into something new here. We left off in that last video looking at something that looked like this. What was it here? It was 1 plus or minus I times the square root of 7. We talked about how this is really an introduction to what complex numbers are. Complex numbers, they sound really complex, but they're not. Complex numbers just means that we're combining a real number with, either adding or subtracting with an imaginary number. So something attached to I, right? And that's called a complex number. So they're not too complex. We can do math with complex numbers. So let's do an example here. If I have 2 plus 3i, that is a complex number. I have a real number first, and I'm adding an imaginary number to it, so that gives me a complex number. So there's one complex number, and I'm trying to add it to another complex number. Okay, so here's our real number, here's our imaginary number, that's another complex number. So this is adding complex numbers. How do we add? Adding is really easy. We just combine like terms. So anything with an I is a like term. That's an imaginary number. We can combine imaginary numbers. And we can always combine real numbers. That should be obvious at this point. But we can't combine the two together. So we always have to leave it as a complex number. Alright, well, let's rewrite it. So we're adding our real numbers, and we're adding that to our imaginary numbers. And really, it's just like terms. So think of I as like a variable. So in order to add these two together, we're just adding their coefficients. So the coefficient of here is 1, right? It's 1i. So we can do 3 plus 1, and we're going to put I on the end of it. Whatever our coefficients add up to, we put I at the end. Okay? So 2 plus 7 is 9. 3 plus 1 is 4, and we're going to stick the I on it. So we get the sum of these two complex numbers is this complex number, 9 plus 4i. And the order that we usually write it in, again, is the real number first and the imaginary number second. We'll get more into that in a sec. Okay, so let's do another example here. Just more of the same. Doesn't matter if our real number is positive or negative. Still just going to combine like terms, combine those real numbers, combine your imaginary numbers. So we could even do it by drawing little arrows. We don't have to necessarily put them in different parentheses. So here we have -4 plus -4. So those two real numbers combine to make -8. And our imaginary numbers, we have a positive 7i, we have a negative 7i. Well, imaginary numbers can also cancel if they're opposites. So a positive 7i minus 7i gives us 0, and 0 times anything, even if it's 0i, becomes 0, so it's gone. And so adding these two complex numbers gave us a real number, and it's just -8. So that can happen sometimes. Alright, so that's adding complex numbers. Let's talk about subtracting complex numbers. I think the easiest way is just to always turn a subtraction problem into an addition problem. So rather than subtracting, we are going to make an addition. I think that's just the easiest way to do it. So here you can think of this as -1 times everything that's inside, or the opposite of everything that's inside this parenthesis. So let's rewrite everything here as an addition problem. That all stays the same. We're going to change this subtraction to addition, which means we take the opposite of everything inside. So instead of a +1, it's a -1. Instead of a positive 2i, it's a negative 2i. And now we just have an addition problem. Just combine your real numbers. 8 and -1 give us +7. 5i and -2i give us a +3i. And we're done. We got another complex number. Let's do another subtraction real quick. 2 minus 6i minus -10 plus 4i. So again, we're asked to subtract two complex numbers. I'm going to change that to addition and take the opposite of everything inside these parentheses. So instead of -10, I get a +10. Instead of +4i, I get -4i. Rewrite that first set as it was, and then combine your like terms. The real numbers are 2 plus 10. That gives us 12. And the imaginary numbers are -6i and -4i. They combine to make -10i. So there you go. I think by changing it to addition, you don't have to remember the subtraction recipe or process, which can get a little confusing if you have to memorize too many things. So I always just make it an addition problem, and then you don't have to memorize a different form. You're just still combining like terms. Alright, so that's adding and subtracting complex numbers. That's not too bad. Just combine like terms. But how do we multiply complex numbers? This is where it starts to get a little bit trickier here. If I have a complex number, 3 plus I, and I need to multiply it by an imaginary number, we can treat this as just a distribution problem. I'm just multiplying things outside the parentheses by everything inside. But we're going to get back to that second definition of I that we talked about earlier. So what do we get? I times 3. Well, that gives us 3I, right? And then I times I gives us a positive I squared. Well, remember that I squared equals -1. So let's rewrite -1 instead of I squared. So it would be -1, right? Or you could say plus -1. That's fine. Either way. But the only thing we have to do here, we're pretty much done. We just need to rewrite it in the correct order. So remember, real numbers come first. So we're basically just swapping these. So I write -1 first, and then I write positive 3i, and that will give me my final answer. This is called standard form. So always write the real number first, followed by the imaginary number. Alright, I think we got enough room on here. We could do another one similar here. Let's just add a coefficient to that I at the beginning there and see what happens. So 4i times 6 gives us 24i, and then 4i times negative 1 gives us negative 4i squared. So just rewrite things. 24i minus 4 times negative 1, right? Instead of I squared, we write negative 1. So now we have negative 4 times negative 1. Well, that's a positive 4. So we got 24i plus 4. Just rewrite it in the correct order. Real number first, and then the imaginary number second. Alright, let's get a little more complicated here. What happens if we try and multiply two complex numbers? So we got 5 plus I, there's one complex number. I'm going to multiply that by 8 plus I, another complex number. Hopefully this looks familiar to you. You think this looks like a FOIL problem, okay? And that's exactly what we do. We FOIL. Do first terms, 5 times 8, that's 40. We do outside terms, 5 times I, that gives me positive 5i. We got inside terms, I times 8, that's positive 8i. And then last terms, I times I gives us positive I squared. Rewrite I squared as negative 1. Combine your like terms here. 5i plus 8i gives us 13i. And we still have that 40 out in front. So as you can see, that I squared turned into a real number. So we still have to combine these real numbers. 40 minus 1 gives us 39. And then we write our imaginary number last. So there's two complex numbers multiplied together. Gave us another complex number here. But what happens? Let's try another example here and we'll lead into the next video. Let's say I have 3 plus I, and I'm multiplying that by 3 minus I. Let's see what happens here. So FOIL again. First terms, 3 times 3 is 9. Last terms, 3 times negative I is negative 3i. Inside terms, I times 3 is positive 3i. And last terms, I times negative I squared, or a, oops, sorry. I times negative I is negative I squared. There we go. Okay, so let's see what happened here. Let's rewrite this as minus I squared, so we have to write I squared as negative 1, and that minus stays there. So now we have negative, or the opposite of negative 1, or minus negative 1. So a double negative becomes a positive, right? So we got positive 1 on the outside there. What happened to our middle terms here? They're actually opposites and they cancel. They go away. So negative 3i plus 3i goes away. And we're just left with 9 plus 1. And that gives us 10. Strange how multiplying two complex numbers gave us just a real number at the end. And there is a reason. This is called a conjugate. Conjugate. There it is. Anytime you see a complex number and a complex number similar to it, and the only difference is the sign. See how this one had 3 plus I, this is 3 minus I. This right here is known as the conjugate of this. So conjugates are the same numbers with just different signs in between them. And we will use this thing called the conjugate to divide complex numbers. So that's our last bit of math with complex numbers, and it's by far the trickiest. But if we know how to find the conjugate, we will be able to divide complex numbers. So you'll see that in the next video.